Hi, guys. Thank you for taking the time to join today. I'd like to thank Redington for hosting us. My name is Shahzad Ali. I head the sales operations at VaporVM. Today, we will be discussing Azure DevOps. Joining with me on the call from VaporVM, we have Adil Muzaffar, who is our data analytics lead. He has 15 plus years of experience, and I've never known anyone to love data as much as Adil, so you'll enjoy speaking to him in the Q&A session. We also have Rohail Khan, who is our DevOps lead. Rohail brings experience in DevOps for the past 3 years, and he has a degree in computer science. We also have Hassan Saeed. He also brings 3 years of experience within the industry, and he has a background in electrical engineering from his university. We also have Hassan Iftikhar, who has 8 years of experience, and he has a degree in telecommunications. During the course of this presentation, I will initially take you through a bit of background about the company, how we started, what we specialize in. So VaporVM is a global company. We are a cloud solutions provider. We are based in UAE. We were founded in 2013. We also have offices in New York and in Lahore in Pakistan as well. Our clientele are dispersed globally. So we have clients in South Africa. We have clients in the Middle East, in North America as well. Next, I will talk to you about VaporVM in terms of numbers. So as a company, we are touching upon around about 100 employees. Most of us are engineers coming from various backgrounds. We have a vendor relationship with 20 plus vendors within the region and globally. We have global relationships as well. We are, in essence, a managed services company. We provide managed services to our clients all over the world. We have 25 managed service customers within the past 3 years. We monitor more than 25,000 endpoints. We have our own NOC and SOC in Dubai and also in Lahore. Our senior management team is well experienced, coming from various backgrounds like Cisco, JP Morgan, and Accenture, as well as others. And we are proud to be gold partners of Microsoft. Next, I'll talk you through some of the services that VaporVM provide. So VaporVM, in essence, our bread and butter is managed services, digital managed services. We are engaged by our clients, and we provide an end-to-end service. We design the solution. We design the service for them. We even provide resourcing where it's required. And we manage their operations, network operations end-to-end. We also manage applications as well. We also have a practice in cybersecurity, where we've had multiple projects within the region and globally as well, ranging from PAPT, hardening, and obviously our SOC as well. We also have a DevOps practice, which is what we're here to discuss today. Our DevOps lead will actually take you through the details of that, but it's well established. Alhamdulillah, we've got projects in flight as well with big organizations in the region. We also have the broader data sciences practice and cloud services as well. I will now leave it with my colleagues to take you through the session today. I hope you enjoy it. If you have any questions, we can take them at the end. Go ahead, Rohail.
Okay. Hi everyone. My name is Rohail. I will brief you about what were the challenges in software development lifecycle before DevOps, what is DevOps and how DevOps changed the current software development lifecycle. A lot has changed in the software development in the last decade. While there are more important changes in the software development lifecycle, the DevOps revolution has made industry waves in a good way throughout a variety of software development companies. Small and large teams alike can have seen the difference when they switch from traditional software development cycles to the DevOps cycle. So what were the development methodologies and what were the problem before DevOps? So before DevOps, the long timeline and delay tend to be the most obvious issues. When a company wants to innovate and make changes, it can take months to implement new software or updates because of back and forth that goes in between development and operations. Both the department have their own separate goals and processes. Software development life cycle times can be extended unnecessarily. More implementation failures can occur more often. These two departments specifically can both benefit from more communication and collaboration. The other huge issue with the traditional software development process is the time between the implementation and the feedback. If any failures are detected by the operations, it could be weeks or months after the code was developed. The developers have already moved on to the next project and are not as invested in what they have already passed to operations. DevOps helps shorten the recovery, provide an opportunity for reflection, and update timeframe as necessary. So, what is DevOps? DevOps refer to the practice of combining software development and IT operation to shorten the software development lifecycle. With those functions happening simultaneously, DevOps help companies roll out new software updates more quickly without sacrificing the quality. The standard way of creating and maintaining software puts two separate departments to work on different sides of the project. Developers plan, design, and build the system from the ground up before passing it over to the operations for testing, implementation, or integration with the existing system. There often a long delay between development and full implementation because of break between development and operation teams. If something needs to be reworked or bug fixed, or if the software doesn't quite meet all the needs of the final user, operation has to pass it back to the development with the feedback and wait for the update. Admittedly, some of the DevOps practices are likely being done at some scale in many organizations today, even if they are not using a specific DevOps tool. Companies may be doing some of the right things without pulling it all together and doing the things right. So here are some of the advantages of adopting DevOps methodologies. So faster delivery. The entire team is responsible for delivering new features as well as the stability of the old software. This helps to expose the problem in earlier stages of development. The resolution times are faster because the development team doesn't need to wait for other teams to troubleshoot and testing. By focusing on business need first, project gets first, which helps to move into production environment. DevOps methodology helps to respond to market demand faster. Stable operating environment. To maintain a stable environment, infrastructure as a code can be used. Server configuration is stored in the source code repository with the application source. Automation tool will take the configuration and apply each task to the desired system. These tools automate any task virtually and are easy to learn. Improved effectiveness. Automated deployments and standardized production environment are the key aspect of DevOps model. This make deployment predictable and people are escaped from the mundane task of routine. People can be more productive and this in return improves the work environment. When people spend time adding value to the organization, it benefits the organization. Collaboration between the team. The effective decision making improves transparency, thereby helps in collaboration of the team. Development teams should collaborate between teams to break down the barrier between different teams and should communicate around the clock in the environment. This helps to improve the business agility, which paves the way for the mutual collaboration, communication, and integration across the global IT environment. This makes all team members responsible for quality and time-bound delivery of the products. Defect correction. When the team collaborates with each other, it helps in easy detection of defects since the testing team is not separated and tasks are not divided for them. When the defects are detected, it is easy to correct it fast and do operationally. This helps in providing the best service to the customer. So let me explain how the DevOps culture enable when an organization adopts a DevOps culture, what are few advantages they have. So after the adoption of the DevOps, it's been shown to help companies build and implement cutting edge tech sooner than traditional development processes. This means companies are less vulnerable to industry disruption because the turnaround time for the updates and development changes is drastically reduced. DevOps is thought for a nearly perfect solution for developers when it is done right. Of course, there is no perfect strategy that works 100% of the time in every context. However, DevOps is a huge improvement over a fragmented system that delays feedback, updates, pitting operation against development in competition to fulfill a separate set of goals. Using DevOps effectively, companies can implement software updates and new programs constantly. It is not uncommon for some development companies to implement 5 to 10 deployments per day, requiring a well-disciplined team with free flow information and feedback. Using DevOps, this process is automated where it needs to be, assisting teams in getting their work done on time and smoothing the deployments. If you have a remote team or any remote workers on the deployment, operation, or production team, DevOps keep everything flowing well, despite the physical and communication challenges. Even with the separate goal and fragmented teams, DevOps helps to keep everyone connected to the process so each member of the team can be more involved in the success of the software. So now Hassan Said will explain how we can adopt Azure DevOps services in our environment.
And thank you, Rohit. Hello, everyone. My name is Hassan Said, and I will be taking over now. Coming to Azure DevOps, the process is similar to any other DevOps adaptation. Firstly, we need to plan our deployment, which includes the understanding of the task's requirements, and then creating timelines and tasks to achieve those requirements in the appropriate time. The second part of the DevOps is the code development. In this part, we need to create an initial draft of our code and then apply the necessary updates according to our requirements. After that, we can commit our code and make an initial build. Once a build is created, we can run unit tests on our code to resolve any issues and deficiencies in the next build. Now, the third part of the code deployment, after a stable build is created, we can deploy our code in the test environment. And once the dev, QA, and UAT testing is done and everything is looking as expected, we can proceed to the deployment of our code in the production environment with the approval from the project owner. The next step is the application testing. Once our automation is set up, we need to test that our continuous integration is working as expected. Are there any performance issues? Is the application security okay? And if we have to review our risk acceptance with the new update. The answer to all these questions will be obtained in this step. Now moving to the final step is the application and performance monitoring. We need to continuously monitor our application so any issues can be foreseen and hence avoided. Also, performance monitoring data will lead us to optimize the performance of our application. All these steps can be performed using various services of Azure DevOps. Now I will briefly introduce you with all these services. Now, the first service is Azure Boards. It is basically a project management service using which we can plan our project. We can create various tasks and can assign these tasks to appropriate engineers. We can also assign the time period to a task. Sprints can also be configured to deploy a part of code in a specific amount of time. We can also create queries, issues, and epics. A backlog of all the work will also be available. Coming to Azure Repos, it is a code repository service of Azure for managing and hosting our code repositories for Git or Team Foundation version control. Azure Repos is primarily designed for Git. It includes features for creating custom branch policies, automation through pipelines, semantic code searching, and all the features that come standard with Git. The next service is Azure Pipeline. This service is the heart of Azure DevOps. Azure Pipeline enables users to manage and deploy continuous integration and continuous delivery pipeline on Linux, macOS, and Windows operating systems. Users also have the option of defining the pipeline to containers orchestrated with Kubernetes. Pipelines support applications in most languages, including Node.js, Python, PHP, Java, Ruby, .NET, and mobile platforms. In pipelines, you can use pre-built templates to get started. If you are unsure where to start, the service can recommend suitable templates based on assessment of your source code. Alternatively, you can create pipelines from scratch using either a drag-and-drop interface or via YAML files. The next service is Azure Test Plans. Test Plans is the Azure DevOps testing service, using which users can create and run manual and automated tests on the code base. It also includes features for exploratory testing, enabling the users to simultaneously create and run tests. Using test plans, users can test both desktop and web application and tie results directly to related work items. The last service of Azure DevOps is Azure Artifacts. Artifacts is a service that can be used to create host and share packages. It supports Maven, Python, NPM, and NuGet, and also includes built-in features for package versioning and testing. Artifacts also enable you to combine packages from multiple sources into a universal package, eliminating the need to store binaries in Git. Now, next, I will be showing you a diagram that's a generalized view of Azure DevOps scenario. In this diagram, firstly, a user will push the code to Azure repos from the personal repository. After that, a build of code is created. Then the user can create two pipelines connecting our repository to our test environment and the development environment. After that, a release will be created and the code will be pushed to the test environment using test pipeline. And after proper testing and approval from the project owner, we can push the code to our development environment using the development pipeline. Now, following this pattern, we will show you two demos. First demo will be related to Azure Web Apps, and second one will be related to Azure Function. But first, I will provide you an introduction to these services. Firstly, I will explain what is serverless compute. Serverless is the native architecture of the cloud that enables you to shift more of your operational responsibilities to cloud, increasing your agility and innovation. Serverless also allows you to build and run applications and services without thinking about servers. It eliminates infrastructure management tasks such as server or cluster provisioning, patching, operating system maintenance, and capacity provisioning. You can build for nearly any type of application or backend service, and everything required to run and scale your application with high availability is handled by the cloud. Some of the major advantages of serverless compute are shown here. No server management is necessary. Although serverless computing does actually take place on servers, but developers never have to deal with the servers. They are managed by the vendor. Cost reduction. As in a pay-as-you-go phone plan, developers are only charged for what they use. Code only runs when backend functions are needed by the serverless application, so no extra cost for server deployment and non-usage time. Quick deployment and updates are possible. Using a serverless infrastructure, there is no need to upload code to servers and do any backend configuration in order to release a working version of an application. Developers can very quickly upload bits of code and release a new product. They can upload code all at once or one function at a time, since the application is not a single monolithic stack, but rather a collection of functions provisioned by the vendor. Scalability. Application built with a serverless infrastructure will scale automatically as the user base grows or usage increases. If a function needs to be run in multiple instances, the vendor server will start up, run, and end them as they are needed, often using containers. As a result, a serverless application will be able to handle an unusual high number of requests. Just as well, it can process a single request from a single user. A traditionally structured application with a fixed amount of server space can be overwhelmed by a sudden increase in usage. Triggers setup. Also, triggers can be set up to run the serverless compute function only at the time when required. Now I will explain about a serverless application that is used in Azure. Now the serverless application that is used in Azure is Azure Functions. Azure Functions is an event-driven compute on demand experience that extends the existing Azure application platform with capabilities to implement code triggered by events occurring in Azure or third-party service as well as on-premise systems. Azure Function allows developers to act by connecting to data sources or messaging solutions through making it easy to process and react to events. Developers can leverage Azure Functions to build HTTP-based API endpoints accessible by a wide range of application, mobile, and IoT devices. Azure Function is scale-based and on-demand, so you can pay only for the resources you consume. Now I will explain about the Azure App Service. That is a managed app service on Azure. So Azure App Service is a service using which we can quickly deploy, build, and scale web apps and APIs on our terms. Work with .NET, .NET Core, .NET JS, Java, Python, or PHP in containers or running on Windows or Linux. We can bring our code or container using framework language of our choice. We can increase developer productivity with tight integration of Visual Studio and Visual Studio Code. We can streamline CI/CD with Git, GitHub, GitHub Action, Atlassian Bucket, Azure DevOps, Docker Hub, and Azure Container Registry. We can reduce downtime and minimize risk for app updates by using deployment flow. We can achieve high availability with SLA-backed uptime of 99.95%. Simplify operations with automatic platform maintenance and security patches. We can protect our application with web app firewall and connect with virtual network integration. We can deploy isolated web app instances with a single tenancy model. We can use Azure Active Directory and other popular identity providers to authenticate and authorize app access. We can bring our web apps to the cloud with minimal or no code changes using the Azure App Service. Migration Assistant is a free and simple tool to automatically migrate .NET or PHP web applications from on-premise to the cloud. Now, I'm going to show a simple diagram showing a simple scenario of a web app deployment. Now, the service is using Azure SQL Database Service as database, while data including images or videos is stored on Azure Blob, which is an Azure storage service. While the access and identity of the service is controlled using Azure Active Directory, and applications DNS is managed using Azure DNS. Now we are going to show you a demo of CI/CD using these services, and Mr. Hassan Iftikhar will take over and show you the demo now.
Hello, thank you Hassan Saeed. Hello everyone, my name is Hassan Iftikhar and I will be showing you the demo of Azure CI/CD pipelines. Due to limited time frame today, we will be focusing on Azure repos and Azure pipelines to help someone new to DevOps use these simple steps to enable CI/CD for their web applications hosted in Azure as Azure App Services and Azure Functions. Now, moving towards our first deployment module, what we'll be doing is we'll involve a .NET Core application with SQL Server running on Azure Web App and Azure SQL Service. The complete flow for deployment will be that if any change is made to the code in the Azure repos, it will trigger the pipeline to deploy those changes to Azure Web App. As you can see in the diagram, we already have Azure repos through which we will make the changes, and in Azure pipeline we will build those changes in a CI process, and in the Azure pipeline's release phase we will deploy those to the web application. Now moving towards our second demonstration that we are going to demonstrate you, what we will be doing is we will be deploying a simple Python application on Azure function. The flow will be the same as the previous demo, that once you make any changes to the code in the Azure repo, it will trigger an Azure function.
Hassan,
Yes,
just speak up a bit.
okay. So now let me share my screen and share with you the demonstration. Now, here you can see we are in Azure portal. So we are in the resource group. So we have some prerequisites for the first demonstration. The prerequisites are we have to deploy an app service with Azure SQL Server and an Azure database along with a container registry. So I have already prepared these three steps for you guys. You can see here we have our app service, we have our SQL server, we have our container registry already deployed. Now let's move towards Azure DevOps, where I can share you the other informations. So this is the main portal of Azure DevOps. What you will simply do is you will create a new project as a private and add it as a private repositories. I have already created those projects. Now let's move towards a project in which we're going to perform this demo. Now we are into this project. Now you can see we can on the left hand side we move into Azure repos, and here we'll see the whole code that we have our .NET Core application. It's a simple application of a health link that we are going to use. So here we have our source code. Now let's move towards the pipelines. On the left hand sides you can select pipelines, and here what we have done is that we have used a template of a pipeline that will build a Docker image and push it to the Azure Container Registry, and from there it will deploy web apps. Now move into this pipeline. What we have to do is to provide some variables along with it. Now for the first part, that is our CI part, continuous integration, in which we are going to build the Docker image, we have to provide certain steps. For the first step, that is the run services. In the run services, what we'll do is we'll put the name as already has been put in there as run services, and we'll provide a container registry type. For our demonstration, we are using Azure Container Registry, so we have provided the Azure Container Registry here. Now what we have to do here is to provide our subscription. In order to provide our subscription, we need to authorize it first. So let's authorize our subscription. Let's wait for a few moments. Once the subscription is authorized, it takes around a minute or so. Then we'll perform the rest of the steps. So now, yes, our subscription is now connected. So now what we have to do is to provide a container registry name here. For the container registry, what we have done here is we have created a container registry already. So we'll provide a name here. There is a name coming, VVM demo org. how whatever container registries you would have in your subscription will be displayed here. So we'll provide this container registry. Now what we'll do is we'll move towards the build stage. In the build stage we have to follow the same pattern. We have to provide a name, we have to provide a container registry type, that is Azure container registry, and we'll have to provide a subscription. After the subscription we have to provide our container registry name, that will be shown here in a moment. Yes, there it is. Now for the push services, in order to push this image to container as your container registry, we need to provide the same parameters. We'll provide a display name, we'll provide a container registry type, and in the subscription we'll choose our subscription, and after that we'll provide the container registry. Now here our build stage is completed, so we'll save it. We'll put a name here as build and we'll save it. Now for the continuous deployment stage, what we have to do is we have to create a continuous deployment pipeline in which it will populate the database that we have created, and it will create a Azure web app from this Docker container registry image that we have created. Let's go towards the release now, and here we have our release pipeline. Names mhc docker.release. We'll edit it and we'll provide some parameters. Now on the top you can see we have certain bar. From that bar we'll select task and we'll go to dev. Now for the database deployment, Azure needs to implement certain an agent that will populate the database table. As we are using the SQL database, what we'll do is we'll provide a Windows agent. That is, the agent name is Windows VS2017 Windows 16. After providing that agent name, what we'll do is we'll move towards the next task, that is to execute Azure Database SQL. Here what we'll do is we'll provide a name here, as we have already created this template, so the name is already there. We'll select Azure Service Connection type. We are using Azure Resource Manager because the classic model is now obsoleted and no one uses it. Now here we'll provide our subscription. After the subscription, what we'll do is we'll move into the web app deployment stage. In the web app deployment, we first need to provide the agent. So we are using here Azure web app for Linux. So we'll use an Ubuntu 16.04 image for the deployment agent. Now let's move towards the web app service deploy part. Here it's simple. We'll give it a name. We'll select our subscription. We'll provide that what type of web app it is. As I already told you that it is a Linux web app. We'll select here. Now we'll select the app service name. So here our app service name is VaporVM demo. It will already populate here once you will select the subscription. Now as an image source, we have selected here the container registry. Now we have to provide certain variables for the configurations. Now here, like, we have to provide our container registry name, we have to provide the database name, its passwords, its admin name, and also the SQL server that we are using. For the web app name, let's move towards the web app and we'll see that our web app name is VaporVM demo. For the database that we have created, it is MHCDB, its name, and its admin name is SQL admin. And for our database SQL server, the SQL server URL is given here. I have already copied this to a notepad so that it will be easy for me to configure. So let's move towards the configurations. First, we'll need to provide an ACR name. We'll copy it from here. And we'll simply edit it here. And what we need to do is provide a database name. We'll provide our database name. And after that, we'll provide its password. After the password, we have to provide the admin name, that is here SQL admin. So we'll provide it here. After providing, we have to provide a URL of the SQL server. Note that for the SQL server, you need to provide the full URL, not only the name. Once you provide the full URL, it will work. Now we'll provide it. It is the deployment stage and we will commit it. Now that our release is configured, what we need to do in order to trigger this, we need to go into our code and we need to make some changes. Once we make the changes into our repo, our release pipeline CI/CD process will start. So for that we have to go into our code, and what we'll do is we'll simply change the front end button on the screen. So what we'll do, we'll move towards home, go towards index.html, and we'll press edit and we'll change this name. Now here in line number 28 you can see that it is written here as join. So what we can do is we can change it to contact. Now we have to commit it. Now, once we commit it, our process will start running, but because it takes around 15 to 20 minutes to complete this build, so what we have done is we have already created this pipeline to show you the end results. But before showing you the end result, let me move into another step that you have to do. Now once everything is deployed, you can move into your container registry, and into your container registry, once the pipeline will complete its continuous integration steps, when you move into the repository, your image will be shown here. Yes, you can see my help.web image is already there. For the next part, what we need to do is we need to configure a web app to use this container image. We need to provide this configuration. For that, we have to move into the web app that we have deployed. We need to go into container settings, and in the container settings, what we'll do is we'll simply select our registry here, that what is our container registry, and our image and the tag. Once we select the tag, then we'll turn on this button of continuous deployment. After doing it, we will have to save it. Once we save it, now our web app configuration part is done. Now for this to work here, you can see here is our already deployed pipeline. So let me move towards the pipeline. It has already been deployed and the release has already been published. So let's move into the release. You can see it has been published, and let me show you in the repos that what I have done. I have simply what I've done, I've went into home directory and I have simply changed in line number 28 from join us to contact us, right? So now when we move into our web app here, we'll go into overview. Here you will get the URL of your web application. You simply can do is copy this URL and paste it in your browser, and you can see your website is up, and from here it should be join us, but instead of join us it is contact us because we have made the changes. Now for the second use case of Azure function, let's move towards that part. Now for the Azure function, what we'll do is, so here is our another resource group, that is VaporVM demo RG2, in which we have deployed a simple Azure function. You can see here is VaporVM function. This is the Azure function that we are going to use. It's a simple Python based function that will display a name whenever you query, and provide a query string with the name in it. So let us move towards the function. There is our driver. Here you can see this is our function that is already been working. So what we'll do is we'll create a CI/CD pipeline through which whenever we make changes into the repositories, it will show up in the end function. Now right now we can see that this is our URL. Let's copy the URL and show to you what it is currently doing. Let me provide it name as VaporVM. You can see that currently it is giving this line that hello VaporVM, this HTTP triggered function executed successfully. Now in order to change it, what we need to do is we need to move into our project of Azure function where we have provide the repositories. Now we move into repositories. Here we have our function code. We have pushed it through our local PC towards this repository. Now in order to create a pipeline, we will move towards pipelines. We'll set up a new pipeline. what we'll do is it will ask you that where is your code. So we have our code in Azure repository, Azure Git repository. So we'll select Azure repositories. This is our project name, Azure function. We'll select the function. Now our function is a simple Python application, so we'll select this Python function app to Linux on Azure button. Once we do it, it will ask us to provide our subscription. We'll check our subscription and we'll select continue. It will ask us to verify, so we will provide our account here, credentials. Once we'll provide our account credentials, it will select this subscription. Let's wait for a moment for it to verify. Yeah, it's verified. Now for the first point, we have to provide a function app name. Here our function app name is VaporVM function. As mentioned here, we use this VaporVM function and we'll leave the default directory as it is, and we'll validate and configure this. Now once validate, it will provide you with the YAML template of the configurations that you have selected. So you can copy this YAML template for future automation, that in the future, in order to redeploy it, you don't need to go through all the steps. You just need to run this YAML template and it will deploy it for you. Now we can save and run here, but it takes around 5 to 6 minutes to complete. So we have already created a pipeline. What we'll do is we'll make changes in the code, and it should once we send an HTTP trigger, it should reflect our changes. So we'll move into python.pf file. What we'll do is we'll press edit and we'll change this line. This was the line that was shown before. Now we'll change this line and we'll see that. Let us change it. And put it, the code is updated now. Once we commit it, let's move into the pipeline. We can see that our pipeline has started to build. Now our pipeline is in the phase of building this, in the build stage. We can go into the build stage and see the job that is going. So currently our job is pending, but it will take around a minute and it will get deployed. So let's wait around a minute and let's see that what happens once this whole build and deploy phase completed. Okay, we can come here back, we can refresh it, we can come back and we'll see it will start now. Yeah, our build stage is completed. As you can see, now it is doing our deployment stage. So let's move towards the deploy part so that we can verify that it is functioning. It is in queue and it will soon be completed. Let's wait here, move towards the deployment stage. Now you can see that it has got the service details. Now it will complete this deployment stage within some seconds and our code will be updated. Now just wait for a minute actually. So this whole process is pretty easy, because if you were doing it manually, you have to redeploy your function every time you updated the code. Now let's see our function. Here was the function URL, and we will refresh it and we should see the change in the code. Now as you can see, our function is changes. Now our code is updated. Now we can see that it is showing that hello, the code is updated. So this was our demo of Azure pipelines. Hopefully that you will have a good understanding about what pipelines are. Now if you guys have any questions, you can share with us and we'll more than happy to answer those questions. Thank you.
Thanks, Hassan. Thank you, everyone, for your presentation. Thank you, everyone, for actually listening and being patient. You are actually welcome to ask any questions. If you want to just maybe pop a question in the Q&A section, you can be unmuted as well if you want to speak, or you can just write. It's up to you. Even if you want to comment, it'd be nice to actually hear what you thought about the actual the material that's been covered, and maybe your thoughts on the topic. Adil, are you on the call? Adil, you still there? Yeah, Adil, do you want to just maybe give your perspective on what's kind of going on within DevOps and how it's actually becoming more and more prominent now than ever? I mean, DevOps actually has existed for quite a while. It's not a totally new concept, but in our time today, right now, it's kind of taking on an even more prominent role.
Yes, Shadab, can you hear me?
Yes, I can hear you.
Okay, good. Okay, overall, DevOps is not related to only CI/CD. That is my impression. I need to give you my understanding. What's the DevOps basically? DevOps is a continuous improvement process. I mean, it can be you can have only implemented on the monitoring side. It can be a continuous monitoring type of thing. So DevOps basically generally divided into two parts: development operations, and then the operations that are related to the operational team. Like, so we need to understand what is the basically the concept, why we are using the DevOps, and why it is aligned to this era. When we have the technology, like when we discuss about the containers, when we discuss about the agility in the development type of thing. So usually on development side, we have a few very common issues, like we have a lengthy deployment issues. Whole the development team is stuck into the deployment type of things, and when you stuck in the deployment type of things, you know the tasks that are already pending, it keeps the way that they remain pending. So when you get yourself free from the deployment type of things, the new task is waiting for you, and the pending tasks remain there. So that basically is a big issue on the development side. So CI/CD is basically helping you to utilize all these tools, so that the development cycle we can improve the development cycle and make it more efficient, fast. And in the meantime, we just need to push the code into the repositories, and repository would automatically handle everything, and through the pipelines that you will deploy the code. But the most important thing is the operation side. Operation side usually have the concern that my environment need to be up for like 99.9%. There must not be any single point of failure, and this is where basically the containerized environments come. Containerized environments give you the agility, gives you the power, so that you can have a replicated environment within the containers using the dockers, and you can say the Kubernetes. We can basically manipulate all these things, so there would not be any single point of failure. Then again, this also helps you to give you the continuous monitoring type of thing. The team need to discuss something on the operational side too. For example, once you have deployed this code, we have the different tools. For example, when I talk about Azure, we have the Azure Monitor, through which we can basically configure all these services. Whatever happens would be available in the Azure Monitor, and from the Azure Monitor we can trigger some kind of, you can say, notification, and any support team that is basically handling all these infrastructure can easily update it and can resolve the issues. So operation is the most important part of this thing. So continuous improvement will come from the operational side. However, the both teams are basically connected. So it's not related to the development environment, but for example, if we are a managed service provider, then we can have an automated, complete, continuous monitoring thing, which will lead us to the continuous improvement thing. This is the concept of basically you can say the DevOps. DevOps is not only confined to the development thing. You can utilize it anywhere where you need agility, where you need automation, where you need rely on the code more than human beings are there. This is my take on DevOps. This subject is very interesting, and this is modernistic. We usually have to adopt this thing. This is the future, actually.
Guys, I'm gonna leave everyone uh, with our website address. So if you can visit the website, it has contact details as well. You can take my email address. Let me just write it down. That's my email address. You can reach out to me anytime if you've got any questions. We can happily take you through the other services we have, or even through DevOps in more detail as well. You can speak to our teammates in more detail if you want. Okay, guys, thank you very much for your time. I think we'll end it here. And then in the near future, inshallah, we'd like to welcome you back for a session on a different topic, or maybe even the same topic, but in more detail. Thank you, everyone.